Hi everyone, I'd like to welcome you to the next lecture in module CO452 Programming Concepts. In this lecture, we're going to take a look at the ArrayList class, which sits in Java's collections framework, and we'll see that the classes within this framework are examples of generics, or in other words, generic classes. Okay, so let's start by having a look at collections. Now, the collections framework contains a number of classes which model data structures. Rather than us having to code these data structures ourselves, they're rather conveniently bundled up into classes which represent them. So those classes contain useful methods and variables that fulfill the behavior associated with those data structures. And we see some examples of them here, such as the ArrayList, the list, the linked list, and the hash map, but there are many other data structures modeled in the collections framework too. And in this lecture, we're not going to focus too much on the differences between them. We'll do that in another lecture. But we'll just focus upon creating an object of the ArrayList class and adding objects to it and removing objects from it. So this is going to be the more practical video where we create an array list and just get used to using it. Okay, so in another lecture we'll unpack the differences between these different data structures here. Okay, so in order to be able to use classes that are contained within Java's collections framework, we need to provide a reference to them. And because these classes are contained within the Java folder, we need to import the class where it's located. So the ArrayList, alongside other collections classes, are contained within the util folder, which sits within the Java folder. So as it's nested quite deep, we need to provide an explicit reference to it. We need to tell our code that we want to refer to it, so we import the class so that we can create objects of the ArrayList within the class that we are importing it. So notice here that we've got an import statement which sits above the class definition. So if there's a class that you want to create an object of the ArrayList of, then we need to import the ArrayList class. Okay, so packages here really just referring to folders. If you ever to look in the Java folder, you should see a folder called util, and if you look inside that, you'll see the ArrayList class. Okay, so we're just basically providing a reference to it so that we can refer to the ArrayList class within our given class. Okay, so that's the first thing we need to do. We need to import the ArrayList, and then once we've done so, we can create an object of it. I said that I wasn't going to talk too much about what an ArrayList is. We will do that in another lecture, but just to provide you a very brief overview, the ArrayList, alongside all the other collections, are just a convenient way of being able to store related objects in one place. Of course, we could create the objects separately and have them exist in their own right, but rather than having to call all the methods on them individually, we can contain them within a collection for easy access to different methods. Okay, we can call methods on each object through referring to the collection's name. Okay, so if we had a series of student objects from a student class, rather than having to call the print method of them individually, we could put all those student objects in a collection. Let's call it students. And then we can just use our for each loop, which we're going to use, as we said in the previous lecture, just to call the print method on those objects. Let's visualize this here. So here on this slide, you see that we've got an ArrayList object called students, and then we've got the student objects underneath it. So if, say, I only had two student objects, one's called Nick, one's called Charlie, They each have their own unique values, of course, the name and the ID, and then they've got their methods all bundled up within those objects. And what we can do is we can create an ArrayList object called students, and those will have references to, point to essentially, the student objects that have been created. And you notice there that they sit within a numbered position within this array list. That's a core idea referring to the array data structure. We'll take a look at that in the next lecture when we talk about arrays, but in arrays, all of the items that sit within an array have an index to them. So they have a position, a numbered position within the array that we can refer to. And we're probably not going to refer directly to the index in our examples here with the array list, but you can get that. There's a method which will get the index at which a particular object sits in. Okay, so here, useful to know that they do have a number associated with them, but we're going to go about finding them a different way. We'll get to that. But anyway, the point is that we just collect a number of student objects and we refer to them through our students object, which is the object of our array list. As we said, the array list is a useful class because it contains lots of other methods that can perform behavior for us. So we've already got preset methods which will add items to the array list, as we're about to do. We can also remove items from our array list. We can clear all of them. We can get the index at which one sits, and we can also return how many are in the array list. So rather than us having to code this behavior ourselves in creating a class on our own, we can just use and reuse what has already been given to us in the ArrayList class. Okay, so let's start by creating the ArrayList object, and then we will try adding items to that object. So the particular syntax we're going to need is similar to creating an object of a class. So hopefully you remember, like variables, we need to first state the type. If it's a primitive type, that would be int, boolean, char, double, etc. And then we have the identifier name. So type and then variable name. If it's an object, we have the class name. If it's student with capital S, and then the student name as our object name. Same principle with the array list. We have to refer to the array list class type, and we have to give it an appropriate identifier. As we said, if we wanted to create a collection of students, we could just call it students. And here's another example where if we wanted to store objects of a product class within our array list, we could just call the collection products because it refers to plural of product. Okay, and the new thing here is the pair of angled brackets, or chevrons if you like, of which the type, you notice there, the type, the class, sits within. So if I want to store student objects within my array list, I have to state that it's going to be student type within the angled brackets there. And then likewise in the second example here, if I want to store objects of the product class, I have to state that it's going to contain product objects. Okay, so, and of course the scope on the furthest left as well, private in this case if it was to be contained within a given class. Okay, so that would give us an object of the array list. And you notice there, those angle brackets are quite useful because rather than having separate array list classes for a given class type, we can have the same class, which is ArrayList, but just customize what type of data we want to store within it. That's an example of a generic class. Okay, so we'll have a look at the format of that in just a moment. But let's finish up by instantiating the ArrayList, because we also, there's our annotations there, we also have to call the constructor of it. And just like we would when we create an object of a class, the first half, which is class name and then object name, and then we assign, use the keyword new, just grabs memory from the heap, and then we call the constructor. Okay, and we can tell it's the constructor here because it's a method. You see the parentheses furthest right, and then the name of the method has the same name as the class. So just like calling the constructor for your creating an object, it's the same here. We're creating an object of the ArrayList class, so we call its constructor. And again, we've passed the type of objects that we want to store. Just to be explicit, there are some examples which don't require this, but just to be really specific, we're going to put that there as well within the angled brackets. So whenever you refer to ArrayList, you would be required to have at least a pair of angled brackets there, even if you don't have to put the type in it. Okay, so that's the full expression which we need to instantiate an ArrayList object from which we can then add items to. Okay, and here we see just a visual comparison, as I've said verbally before. If you just wanted to see the proof that the two are similar, here it is. You notice here that they follow similar type. The only difference is that we have to have the type with the ArrayList, as it's an example of a generic class. So I think that's the next thing we're going to talk about. It is, yeah, so let's talk a little bit more about generic classes. And there are always known, you might hear them referred to as parameterized classes, and they have that diamond notation, the angled brackets, or chevrons as well as they're known. And within that, we can put a type. And that type at the class definition is then substituted for different placeholders that sit within the class. Okay, if we have a look at just a portion of the ArrayList source code, this is taken from Oracle. I've got the full reference right at the bottom there. You can look it up. If you just go to oracle.com and type in ArrayList into their documentation, you'll see a much more expanded version of this one, but this is just to give you the main points. And if you have a look at it, you'll notice that at the class declaration, after the class name ArrayList, you'll see the angle brackets followed by a capital E. Now that E in this case refers to element, but that it will be substituted for the type that you instantiate the ArrayList of. So if it's students, you then can replace the letter E with student class, so that when you add objects of the student type, it knows that it's dealing with that type. And likewise with removal as well. If I'm going to be returning the item removed, it's going to be a student type, so therefore I need to replace that letter E with the type. But you notice in the second example, I had a collection of products. So we can reuse this class, but just change the type. Rather than having to create a whole different class or a whole new set of methods that work just with the product class, I can just substitute the letter E for the given class, which is product. Okay, so it's that's what is broadly known as generalization, where we make things less specific. Okay, we're just writing a template here, which can be substituted for specific types. Okay, so let's move on. All right, so now that we've set up the ArrayList, created the object, a lot of syntax there, I do appreciate that. But hopefully you'll see the similarities between creating an object of a class here. The only addition is the diamond notation, which is the pair of angle brackets. So once you've got that set up, you can then call the add method on the ArrayList object, which students in this case, and then in the parameters, you can pass your student objects. So before in the visualization, you saw I had two, so let's add a third one. So here we go. In order, they would be added like this. And remember, they have numbered positions. So as with the array, they start at 0. Just remember that. We don't have to worry too much about the index with our examples, but just be aware of it. And the last student, Sophie, is added to the end of the list, added in order, remember. So that will have the third position, which is element 2. Okay, so that's fairly straightforward to be able to add items to the array list. You can also insert mid-list as well. There's ways of doing that, and sorting them, of course, if you wanted to sort them in alphabetical order, but we're just going to keep things really simple and just add to the end of the list in our examples here. So make sure you add them in order. And what we can then do, as if you remember back to the previous lecture where we talked about iteration, we introduced the for each loop right at the very end of the lecture. And we said we'd continue the conversation when we got to collections. So here we go. We're going to resume what we were talking about with the for each loop. So if you remember, for each loop is where we refer to a collection. We've got our students collection. It sits on the right-hand side of the colon. And then we create a reference, a temporary object, if you like, just refers to each one of the objects in the collection. It's of student type, so that's why we see the student class there, and then the temporary object is student. That's the placeholder for all of the objects, one at a time. And then through that placeholder, one at a time, we can call the print method for each of the student objects within our array list. Okay, so that's hopefully filled in a few gaps there with what we're doing. So printing out the items in order, again, isn't too difficult once we've got a handle on how to use a for each loop and how to create a collection. There we go, there's our annotations, as we said. And let's move on to something a little bit more taxing now. Let's look at how we might find an item in an array list. So we could take the for each loop that we had for printing them, because essentially we look at one at a time and we can find something to compare. So for example, if I wanted to find a student object in my collection, let's say I had 3 objects in there, I could look at the ID values and then see if I can find a match with the one that I'm looking for. So the full code here, remember the for each loop sits in the middle of this method. And this method, let's just say I want to find a student method by their ID. So find a student object by their ID. If I pass in an ID that I'm looking for, I can then call the getID method on each of the students within the array and check to see whether the value returned from that specific student object matches with the one that I'm looking for. So that's the innermost if statement here, you'll see that. And if I find a matching one, then I return that student object. And that's the return statement, again, most embedded here. But if you have a look at the return value, you notice that's of student type there. So that's why the return value is student there, because I want to return something of type student, which is my student object, if I found it. But if there's an example where I go through each of the student objects and I don't find it, then right at the very end, because I'm required to return something, I'll just return null. Okay, just say we didn't find anything. Let's give you a visual example of this that might make it a little bit easier to follow. So let's say I wanted to find a student object with the ID of 4231. Let's look at the very first student object in my list, which is Nick. Okay, let's look at the ID for that, which is 1234. If I call the getID method of this object, student.getID, that returns 1234, and then I compare that with the one that I'm looking for, which is 4231. So are those two the same? No, they're not. So that's false, not equal. So therefore I don't return the student objects, and I move on to the next item. So again, just a reminder about the code, that's what we're doing. We're calling the getID method for each of the student objects in the array list. Okay, so if it's not that one, then we iterate, we move on to the next student object, which is Charlie. And then we have a look at his ID, which is 5432. Return that, compare it with the ID which we're looking for, which we passed in, which is 4231. Are they equal? No, they're not. So we repeat the process. It's false. So therefore we iterate again. and we move on to the next, which in this case example is the last object to look at, which is Sophie, and have a look at her ID, which is 4231. We return that and compare it against the one that we're looking for, which is 4231. Are they the same? Yes, they are. So we've got a match. It's true, the comparison. So we return that student object. Okay, we have successfully found a student by the ID that we're looking for. Okay, so you can apply this concept to any attributes. You can find by name, find by other attributes as well. There's lots of different customizations there. But just to give a very basic example, we can also, if we knew the element at which it was stored, we could go directly to that. So that's one of the advantages of using an array. We'll see that in the next lecture. But assuming that we don't know what position in the array that our objects are stored in our array list, then we'd have to look at them one at a time. Okay, so that's finding an item within the list, which is very useful because that find method can be applied to the removal. Because of course, if we want to remove an item from our collection, we don't just remove any old item, we want to remove the right one, don't we? So first, we have to locate where the item that we want to remove is in the list. And then once we've found it, then we remove that one. Okay, so the very first step in the removal process is to find the object that we want to remove. So if we were to create a remove method here for our students, we first call the find by ID method, which is what we've just walked through, pass in the ID that we want to remove, and look for it, of course, and if we find a matching one, then return it, store it in an object here, which is students, and then we've got a conditional underneath that. We're saying if student is not equal to null. What does that mean? Well, that basically means, is there something there in student? If it isn't null, then we must have returned something, must have found something. So assuming our find algorithm works okay, then we found the right student. So therefore, if there's something there, then we call the remove method of the array list. That's given to us. We don't need to do that ourselves. That will tidy everything up at its end and remove that object from the collection. Okay, and of course, if we do return null from our find by ID method, if it couldn't find it in the list, if something went wrong, we typed in the wrong ID or something, then we don't want to remove something by mistake. We don't want to remove something which shouldn't be removed. So the else condition here is that we couldn't find the student. Okay, so just remember that process. First of all, find the object you want to remove, and then once you've found it, then you can remove it. Okay, there's more to say about the removal process, but we'll cover that in the next lecture. Okay, so that brings us to the end of our practical part on setting up an array list, seeing how it's an example of a generic class, where we give it the type, and we've looked at how we add items to our array list, looked at finding items within our array list, and we've now looked at how we remove items from our array list. So I hope that was beneficial. In the next lecture, we'll talk about data structures and arrays more. So thank you very much for listening. I'll see you in the next lecture.